All right, guys, 7-5. We need to solve one of these um, questions, solve one of these equations. All right, let's pick number 5, right? One thing you want to do, remember, is to isolate this radical. So that means we need to add 7 to both sides, which gives us square root of 2x plus 3 equal to 7. Then we square both sides, and this becomes 2x plus 3 equals 49. Now we subtract 3, and this becomes 2x equals 46. Divide both sides by 2, and x is equal to 23, right? Let's plug that in and make sure that it works. 23 times 2 is 46. 46 plus 3 is 49. The square root of 49 is 7. 7 minus 7 equals 0. Okay, that is it for that problem. Okay, moving on. Now let's pick number 10. All right, so picking this one. Again, we want to isolate this term, get it by itself. So the first thing I'm going to do is to divide both sides by 3. So that's going to leave me with x plus 3 raised to the 3/4 equal to 27. Okay, well, I'm going to rewrite this 27 because I know that it is equal to 3 to the 3rd. Okay, now in order to get rid of this exponent, I'm going to multiply by its reciprocal. So that would be 4 over 3. And I'm going to do the same thing over here, because what I do to one side, I must do to the other. Here, these cancel out, and we're left with just x plus 3. Here, the 3's cancel out, and you're left with 3 to the 4th power. Okay, 3 to the 4th power is going to be 81. So we have x plus 3 is 81. Let's go ahead and bring this over here and finish it. We're going to subtract 3 from both sides, so therefore x equals 78. And this would be your answer. All right, looking at our extraneous solution, friends, number 17. Ooh. All right, let's add 5 to both sides because we want to get this radical by itself. So we have square root of 3x plus 13 equal to x plus 5. I need to square both sides to get rid of that radical. So this gives me 3x plus 13 equal to, now remember, this is not just going to be x squared plus 25. This is going to give you this property here. A plus b squared is equal to a squared plus 2ab plus b squared. All right, you need to know that. X squared plus 10x plus 25. Okay, I have more terms on the right, and it looks like it would just be easier to erase the ones from the left, eliminate the ones from the left, and move it to the right. So I'm going to subtract 3x from both sides and also subtract 13. And that leaves us with 0 on the left, x squared, plus 7x plus 12. Now, are there factors of 12 that would give me a 7? Yes, there are. So that's x plus 4 and x plus 3. 4x plus 3x is 7x. 4 times 3 is 12. All right, now these are both set equal to 0, so we need to solve each of them. So we have x plus 4 is 0, or we have x plus 3 is 0. So subtract 4, x is negative 4, or we subtract 3, and x is negative 3. Now we need to check both of these solutions in the original problem. So I'm going to plug negative 4 in. I'm going to do this over here. I'm going to put check. Okay, so we've got 3 times negative 4 plus 13. Got a little crazy with the radical there. And then minus 5. Does it equal negative 4? All right, 3 times negative 4 is negative 12, right? So this would be negative 12. Negative 12 plus 13 is going to give us a square root of 1. Square root of 1 minus 5, does that equal negative 4? You bet it does. So yes, this one is a solution. Now let's test the negative 3. So we have 3 times negative 3 plus 13, again, craziness with the radical, minus 5, does that equal negative 3? 3 times negative 3 is negative 9. Negative 9 plus 13 is 4. Square root of 4 is 2. 2 minus 5, does that equal negative 3? It sure does. So this is also a solution. So in this case, we don't have any extraneous solutions. Nifty. All right, moving on to the last one from this section. Solve and check for extraneous. Yep, okay, these are all fraction exponents, rational exponents. Oh, oh no, they're not. I'm sorry. Let's go ahead and do 27. The first thing I'm going to do is isolate the two radical expressions. So I'm going to add 2x plus 7 to both sides. So now we have 3x plus 2 to the 1/2 is equal to 2x plus 7 to the 1/2. In order to get rid of this fractional exponent, we're going to multiply it by, we're going to raise it to the reciprocal, or take both of them to the power of 2. Remember, what we do to the left, we have to do to the right, so that's why these are both 2's, and 2 is your greatest or your least common denominator. Okay, so these cancel out, and you have 3x plus 2 equals 2x plus 7. Subtract 2x from both sides, and we have x plus 2 equals 7. Subtract 2, and we have x equals 5. We do want to double check that just to make sure it is feasible. So plugging 5 in, 3 times 5 is 15, 15 plus 2 is 17. So that's 17 to the 1/2, minus 2 times 5 is 10, 10 plus 7 is 17. So yeah, 17 to the 1/2 minus 17 to the 1/2 is 0. Voila. All right, 7, 6. The composition. First one should be easy, right? Let's do number 7. F plus g of x is the same as f of x plus g of x. Oh, my nose. We have, let me write that. F of x plus g of x, which in this case is 3x plus 5 plus x squared. None of these are like factors, like terms, so I can't combine them, but I can write it in standard form. So this would be x squared plus 3x plus 5. And this would be the answer. All right, going to a composition, the ones that are really tough for you guys. All right, I am going to pick one from the second half, just so I have room to work. Excuse me. Let's do 35. G of f of 3.5. So this translates into G of f of x. X is 3.5. Okay, so the first thing I'm going to do is replace this f of x with the expression that f of x is equal to. So this becomes g of x squared. Well, now I'm going to go ahead and put in this 3.5 for x, right? So this is g 3.5 squared. Using the calculator, we've got 3.5 squared, 12.25. Okay, so this gives us g 12.25. Now I'm going to replace any x in the g equation with 12.125. So this gives me 12.25 minus 3, which is going to give us 9.25. Sorry, I'm going to erase that and rewrite that because it's just sloppy. Right, so 9.25. And that's it. All right, moving on to 7-7.